All right, so I just want to show off some examples of factoring. Um, this section looks at how to factor polynomials, and I just want to go over some of the high points here. So first one we'll start off is the first way you should always look at factoring is by looking at find the greatest common factor and factoring that out um, to simplify your expression. So a little example of this, something like 3x squared minus 12x plus 21. So if I look at this, I try to figure out, well, what is common, the greatest thing, the greatest term that is common to all terms. Well, look at the x's. There's two x's here. There's one x there. There's no x's here. So it can't be any of the x's. Look at the numbers, 3, 12, and 21. The number that evenly divides all three of those is 3. So in this case, I can factor a 3 out, leaves behind the x squared. So basically, when I figure out my leftovers, I divide each term by the GCF. So divide negative 12x by 3, I get negative 4x, and divide 21 by 3, and I get 7. So that's sort of the first example. If I expand on this a little bit, let's look at something like 4x squared y to the third plus x to the fourth y minus 11x to the third y to the second, and we'll throw in a z in there. So if we look at this case, again, looking at what's common to all of the terms. Well, the numbers wise, there's 4, 1, and negative 11. So there's no number I'm going to take out here in this case. Looking at the x's and y's, so I have 2 x's in the first term, I have 4 x's in the second, and I have 3 in the third. So the most that I can divide out evenly is 2. And the y's, I have 3 y's in the first term, 1 in the second, 2 in the third, so I can take out 1 y. And the z is only in that last term, so I can't take that out either. So I'm dividing out an x squared y out of this. So when I divide it, I get the leftovers, so I have 4, both x's are out, and I have 2 y's left behind. Plus the second term, I just have 2 x's left. And the last term, negative 11, and I have an x, a y, and a z. Because the idea here basically is if I multiply this back out, I should get back to where I started from. So that's the concept of doing GCFs. So I'm going to switch gears here to special products. So there's 3 common special products. Basically, the first one is difference of 2 squares. So I'm given something where if I have 2 terms that are both squared subtracted, it factors to a plus b times a minus b. Example of this could be something like 9x squared minus 16. Let me get rid of that. 16y squared. So if we look at this, basically 9x squared is the term 3x being squared. And 16y squared is basically 4y being squared. So my a is 3x, my b is 4y. And I plug it into my formula. So it's 3x plus 4y and 3x minus 4y. So that's using a difference of 2 squares. If it's a sum of 2 squares, if it's like a squared plus b squared, that's prime. So if I can take out a common term, I take that out, but other than that, I can't factor it any further. It has to be a difference of 2 squares. Looking at cubes, these are never memorized, to be honest. But the same concept with 2 terms, a cubed plus b cubed. it factors to a plus b times a squared minus ab plus b squared. And then difference of two cubes. It's very similar, but the first term is now a minus b, and the second one is a squared plus ab plus b squared. So it just fits into the formula. So for example here, could be something like 16a to the third plus 54 x to the 6. And so first it's like, oh, nothing is there's nothing cubed here for these things. But also if I look at them, I can notice that there's a 2 in each case. So if I factor the 2 out, a 8 times a cubed plus then the 27 x to the 6. And now I can do a different sum of 2 cubes. Or my first term is 2, my a basically is 2a cubed, and this is going to be 3x squared is being cubed. So b is 3x squared. So put that in my formula. So I have basically 2a plus 3x squared times 2a squared, which is 4a squared, minus a times b, so it'd be 6ax squared, plus b squared, so that'd be 9x to the fourth. If I just square the b term for that. Difference of two cubes is done the same way. Just the formula, the signs are off by a little bit there. So that's special products. Next thing I want to look at is trinomials. For trinomials, basically, the easier case is where if I have x squared plus bx plus c. It's going to factor to basically x plus or minus something, and then x plus or minus something. These numbers that are in the blanks, so the guy that's sitting, whatever number I have here and there, they have to multiply to c, and they have to add to be b. So that's sort of the little shell game to play here. They have to multiply to be c, but they have to add to b. So let me show a few examples of this. So let's look at x squared minus 3x minus 21. So again, when I factor this, since the x squared is by itself, so are the x's. That will change later. Now also, since the sign on a constant term is negative, this is going to alternate one positive, one negative every single time. If this is positive, the constant term is positive, then the signs inside the parentheses are going to be the same, and they'll be the same as the sign on b, just the way it mathematically works out. So here I want two numbers that multiply to being negative 21. At the same time, they need to add or subtract to negative 3. So if I think of my pairs, I say, well, 1 times 21 is 21. 1 positive, 1 negative. And 3 times 7 is 21. And I think I just messed up my numbers here. Sorry about this. So I'm going to change my numbers here. Trying to do off the top of my head, and I messed up. Let's make that 4. So again, multiply negative 21, add to negative 4. So again, one positive, one negative. The sign, either one could be positive versus negative. So in this case, I'm going to go with the 3 and the 7. Basically because they multiply 21, and they add to or they subtract the 4. So basically, if I put the negative 7 there and the 3 there, x plus 3 times x minus 7 gives me back to x squared minus 4x minus 21. Let me show one more example of this. So let's go x squared plus 8x plus, I should get the numbers right this time. Let's go 15. So for my parentheses of x and I have x. So numbers that multiply to 15 that also add to 8. So 1 and 15. And 3 and 5. 3 plus 5 is 8. That's the pair I want. So since this is positive, so are both of these. And I have 3 and 5. If I multiply it back out, I should get back to where I started from. So hopefully this helps make. Actually, I'll do one more before I stop. So let's look at x squared plus plus 10x minus 24. So my parentheses, again, I'm going to set up, basically I'm doing here reverse FOIL. Since this constant is negative, these are going to alternate, one positive, one negative. So these numbers that I'm going to multiply to 24 that also are going to subtract basically to being 10. So I have 1 times 24. I have 2 times 12. I have 3 times 8. I have 4 times 6. So looking at the pairs here, 24 minus 1 is 23. Nope. 12 minus 2 is 10. So that's the pair I want to work with here. So since this term is here positive, I want the 12 to be positive and the 2 to be negative. So if I FOIL this back out, I get back to where I started from. So hopefully this helps with factoring.